that simplifying value of 7.25 into 10 to the power 47 into 10.225 into 10 to the power minus 15. Though both calculations simplify, we will get the 8.88 into 10 to the power 32. In bracket, simplified value is the 8.47 into 10 to the power minus 3. So the finally simplifying the above calculations, we will get the ZAB is equal to 7.77 into 10 to the power 30, that is a collision frequency. So for the biomolecular reactions involving the chemically similar molecules, and the values are the A plus A gives the products, then the ZAA is equal to 2Na square sigma A square under root pi kt divided by m, or the ZAA n square sigma square under root pi RT divided by m. So this all about the equations, and we are putting the values again in these equations. We will get the simplified answer, that is 1.971 into 10 to the power 30 centimeter cube per second. So this is another way to explain and find out the value of ZAB. So next one is the rate of the effective collision, which involve the energy of activations. So the kinetics of the decompositions of Hi gives the value of ZAA is equal to 3 into 10 to the power 31 collisions per centimeter cube per second at 283 degree kelvins. So the rate constant K was the 3.5 into 10 to the power minus 7 decimeter square per mole per second. Using kinetic equations, the rate is equal to K into concentration of Hi at concentration 1 mole per decimeter cube. The calculated rate shows that 2.108 into 10 to the power 14 molecules decomposing per centimeter cube per seconds. So thus the rate is equal to, ratio is equal to effective collision divided by total collisions is equal to 2.104 into 10 to the power 14 divided by 3 into 10 to the power 31 is equal to 7.01 into 10 to the power minus 18. So this is the calculating part, and the calculations are the of the above equations, indicating that the only out of the 0.8, indicating that the only out of the 0.896, according to Maxwell-Boltzmann distributions of the molecular velocities, the majority of the molecules travel with the average velocity which constant at the given temperatures. Means the, if you consider the any gaseous molecular systems at that times, you find that the maximum, there are a number of molecules the having the some velocities, but the majority of the molecules travels with the average velocity which is constant at a given temperatures. Means that the temperature is the deciding factor for the velocity of the molecules, which because the velocity is concerned with the collisions also. As the velocity increases, the collisions per molecules is also increases. So the velocity is particular temperature is the constant as the velocity increases with increasing some relations with the temperature is also. So the number of molecules traveling with a very low or the very high velocity is a very small. So the fractions of the total molecules possessing the particular energy E is plotted against the kinetic energy per mole for two temperature T1 and T2 differing by 10 degrees centigrade. So the kinetic energy per moles Fe is given by T1. Here are the temperatures also given, because the temperature is the deciding factors for the kinetic energies. So the T1 is the values are the highest value, and the T2 is always greater than the T1. So we will get the maximum